Fine, in this particular video, you are going to learn the square root of irrational number using Bakshali method. See, let us check out here. Right. So, the Bakshali manuscript basically is famous for the sutra which we referred in this particular video as Bakshali Sutra for the approximate computation of square roots of non-square numbers. Right. So, the Bakshali manuscript, which was unearthed by a farmer in 1881, a farmer unearthed, right, at Bakshali, a village near to Peshawar, contains mathematical aspect are written on about around 70 birthmarks. The period of composition of the Bakshali mathematics is placed in the range 200 to 400 AD. Right. The details about which can be found in B. Datta, that is Bhutibhushan Datta, and Martin Levy and Marvin Petrarch. The manuscript was edited with an elaborate introduction by G.R. Kaye and published in 1927. Right. So this particular the formula which is going to be like this. See square root of a. This is a non-perfect square. If you want to find that irrational number square, then so it is going to be a plus, right, r by 2a. You should remember this, minus r by 2a whole square, right, that divided by 2 into a plus r by 2a. Right. So only up to this is enough, so that you can easily get after that is 2 decimal points. Right, after the decimal point you are going to get 2 digits. If you want further, so you can adapt this. It is similar to the previous method only, which I explained using the Sutra Vilokanam. Right. So the techniques for approximate computation of square roots were known to Indian centuries before Christ. For instance, the Jains of India who approximated pi, the value of pi is going to be square root of 10, right, were able to obtain the square root of 10 corrected to 13 decimal places, right, which may be wrong, but it is they approximated, right. So see, it is also called as Iran's formula after the Greek mathematician Iran, who lived in the second half of the century, right, of the first century, right. So here in Iran's work, the formula, this particular formula occurs in connection with a geometrical problem, while in the Bakshali script or Bakshali mathematics, the square root formula occurs in connection with an algebraic problem. This is highly characteristic of the development of early Greek and Indian mathematical thoughts, which developed independently. The Greeks specializing in geometry and the Indians in algebra. Right. Let us go with the working aspect of this particular sutra. Let us find out the square root of 41. To start working on this, right, square root of 41. So the formula that I told you, that is going to be a plus r by 2a minus r by 2a whole square, that divided by, right, twice a plus r by 2a. Right, here a and r, right. Let us check out what exactly a and r. R is the deviation, right, from the perfect square, right. So let us check out here, right. So square root of 41 we can write as what? 36 and as well as 5, right. 36 plus 5 is going to be 41, right. Right, this 36. Right. So now what we can do here is 36 can be extracted as 6, right. The root of 36 is going to be 6 plus 5, right. So where a is equal to 6 and as well as r is equal to 5. This is difference and this is a perfect, the root of the perfect square, nearest perfect square. Right. Let me substitute here to get the answer here. A is equal to 6 plus r is equal to 5 by 2a, that is 2 into 6, that is going to be 12, minus r by 2a whole square, that is 5 by 12, whole square, that divided by 2 into 6 plus 5 by 12, right? 6 plus 5 by 12. So now let us simplify it here. 5 by 12, right? 5 by 12. So take a decimal point, 0, 12 fours are, right? 12 fours are 48, right? Correct. So 12 fives or 12 fours are 48.4, right? And then further division is required, or otherwise you can keep it as it is, then you can subtract it by, that is with fraction only, that is going to be, so let me go with this. So 6 plus 5 by 12 minus 5 by 12 square, which is, I can rewrite 5 5 is a 25 by 144, right? Then that divided by, right? So here take a LCM here, 12 6 is 72 plus 5, that is going to be 77 by 12 into 2, right? That is 144, right? 77 into 2, right? That is 154, right? Or otherwise write down as it is, 2 into 77 by 12, right? 77 by 12, right? Simplify here. Now this will become 6 plus 5 by 12 minus, so 2 ones are 2 6 are, this I can rewrite 144 into, right, 6 by 77, right? So now you can simplify here again. So if you simplify here, 6 ones are 6 twos are, right? And as well as 2 remainder 6 6 are. So this will become 25, right? 25, that must be divided by what? 77 into 26, or otherwise if you, that is 77 or 26 into 25, 25 divided by 26, let me do it, 0 point, right? So 0, this is going to be 9, right? 9 6 are 54, 5 carry, 9 2s are 18 plus 5 to 34, right? 16, right? Take a 0 again, 26, 5s are, right? 5 6 are 30, C 3, 5 2s are 10 plus 3, 6, let me go with it, 6 6 are 36, so 3, 6 2s are 12 plus 3, 15. So 0.96 we got. This will become 6 plus 5 by 12 minus, right? So this is going to be 0.96 by 77. If you further divide, so this will become 6 plus 5 by 12 minus, so 0.01352. Now simplify this. If you simplify, you are going to get 6.403, right? So therefore the square root of 41 is going to be 6.403, right? So I don't think it's required for most of the cases, like in competitive exams. Up to here it's enough to calculate. Only I'm going to show 2 problems, so that other problems directly we can work with the a plus r by 2a, right? Let us check out here. So now we need to find out the square root of 78, right? We know that a plus r by 2a minus r by 2a whole square, that divided by, right, twice a plus r by 2a, right? So here a is equal to, the nearest perfect square is going to be 8 square, that is 78, which lies in between 64, that is 8 square, and as well as 81, 9 square. You can take either this or this, right? Let me take this here. This is going to be 8 plus r is equal to the difference, right here, that is 78 minus 64, which is going to be 14, right? 14 by 2 into, it is 16, minus, right, that is going to be 14 by 16 whole square minus 2 plus 8 plus 14 by 16. So let me simplify 14 by 16, which is going to be 2 7s are 2 8s are, right? So which is going to be 8 plus 7 by 8 minus, so 7 by 8 whole square, that divided by 2 into this is, right, 2 into, right, so 8 plus 7 by 8. Right. Now, so simplify here, 8 plus 7 by 8 minus, so this I will write 7 7, that is 49 by 64 into, right. So now simplify here, right, 2 into, right, so 8 8 is 64 plus 7, 71 by 8, 71 by 8, 71 will be here, and as well as 8 will go here. Right, simplify now, 8 ones are 8 eights, so this will become 8 plus 7 by 8 minus 49, that divided by 70, 1 into 2, I forgot that 2 also, right. So now 8 2s are 16, right, 16 into 71, so 6, 1 1s are 1, 7 6 are 42, plus 1 43, 4 7 1 is 7, plus 4 1 1, 11 1 1 3 6, right. So now we need to simplify this. To start working on this, right, this will become 8 plus 0.875 minus 0.0431, which is nothing but 8.8319. So this is what the square root of 78, right. So square root of 78 is going to be 8.8319. So this particular part is going to take time to calculate. Only this is enough. Let me go with the third problem, right. So in case of third problem, right, that is what is the square root of 128. We need to find out here, square root of 128, right. 128, which lies in between 12 square, that is 144, and 121. This is 11 square and this is 12 square. So therefore A is equal to 11 and R is equal to 128 minus 121, which is going to be 7, right. So the formula is going to be what? So that is A plus R by 2A minus R by 2A whole square, that divided by 2 into A plus R by 2A, right. So first you need to find this and substitute here. It will be easy for you, right, to calculate. Otherwise this much is only enough for up to 2 decimal places, right. This will become now 11 plus 7 by 22, that is A is going to be 11, 11 to 22 minus, so here 7 by 22 whole square, that divided by 2 into A is equal to 11 plus 7 by 22, right. Now, so this will become 11 plus 7 by 22 minus, right. So this 7 by 22, I'll write down like this, 7 by 22 into 7 by 22 into, so take a LCM for this, that is going to be 11 plus 7 by 22, 22 into 11, 22 into 11, 22 into 11, you know how to calculate, 2 to 2 are 2 plus 2 4 and 2 242, right. 242 plus 7 which is going to be 249, right. So this will become, right, 22 will go upwards, right, this is 22, right, 22, that divided by 2 into 249. So 122 will be cancelled. So now the remaining numbers will be 22 minus 7 by 22 into 7 by 22 into 1 by 2 into 249, right. Now if you simplify this, so what you are going to get, that is 7 by 22 minus, right, so 0.00447, right. So the answer is going to be, when you simplify it, so you are going to get 11.31, right. So therefore the square root of 128 is going to be 11.31, right. I told you there is no need to go further here, right. So only thing, up to 2 digits is enough. After the decimal place, that is after the decimal point, only 2 decimal is enough. So let us check out here. The next one is, right, find the square root of 254. 254. So here we know that a plus r by 2a, right, where a is equal to perfect square, so which is going to be, right, 254, which lies in between 15 square, which is going to be 225, and 16 square, which is going to be 256. I'll take this. So a is equal to 15, so r is equal to, that is going to be 254 minus 225, right, 9, right. So 4 minus 2 is 2, 29, right. A is equal to 15 plus how much? R is going to be 29 divided by 2 into 15. 15 plus 29, that divided by 30, right. Now simplify it here. So 29, that divided by 30, so 0.077, that is going to be 270, right. So which is going to be, so 20, you can take 0, so 6, so 180, you can stop here, right, which is nothing but 15 plus point, this is 9.96, right. So 15.96 is the square root of 254. If you want a further decimal places, then you need to go with that particular minus, that is r by 2a whole square, that divided by 2 into a plus r by 2a, right. Let me go with one more example here. So we need to find, see, this is 9368, so that is a plus r by 2a, we will find out. So this we can write, right. So one is the perfect square, we need to find out here. To find the perfect square, this is going to be 9378, nearest perfect square. Make two digits as one group. This is one group and this is one group. So don't bother about this. This let us find out. This 93, which lies in between 10 square and 9 square, where 9 square is 81 and 10 square is 100. So now let me find out, so 95 square, because there should be 90 is going to, 90 square is going to be 8100, 10, so 100 square is going to be 10,000. So this should lies in between this. So 95 square is going to be 9025. So here 9378 is there. So this should be in between this 9378 should be in between 95 to 100. So we know how to find out here. 9378, this is 95 square is going to be 9025. So let me go with 96. Let me go with 96 square. That is by using Yavadunam. So 100 minus 96 is 4. 4 square is 16, right? 96 minus 4 is 92. Right, this is 9216 we got. So let me go with 97 square. So 100 minus 97 is 3. 3 square is 0, 9, 97, 94. So this is becomes 9409, 97 square. 96 square is 9216. So let me take this 96 plus, so 96 square we found, that is 9216. So R is equal to 9378 minus 9216. 8 minus 6 is 2, right. So 7 minus 1 is 6, right. 162, that divided by 2 into 96. Now simplify it here. So 2 ones are 2 8s are 1s are. So this will become 96 plus 81 by 36. Now both are multiple of 3. Let us go with this. So 3 27s are 3 3s are 3 2s are. So 96 plus 27, that divided by 32. So 0. So take this. So 32 6 are. 32 6 are. Right. 32 6 are. 6 2s are 8. Right. 7s are 8s are. Not 6 are 8s are. 8 2s are 16. 1 carry. 8 3s are 24 plus 1 is 25. So 14 we got. Right. Take 0 again. 32 4s are 4 2s are 8, 4 3s are 12, 128. You can stop for here, otherwise you can go further. So this will become 0.84. So the now answer is 96.84. Right. So square root of 9368 is going to be 96.84. Right. Let me go with one more example here. Right. So find the square root of 27,912. The challenge is here, you need to find the perfect square, nearest perfect square. Right. Let me find out here. So 27912. Make two digits as one group from the right. So this and as well as this, you leave this. Now 279. Where exactly 279 comes? So which comes between 16 square and 17 square. 16 square is 256 and 17 square is 289. So you can take 16. That is 160 to 170. This particular number lies. That is square of 160 square and as well as 170. So let me go with the middle one, 165. Right, you know how to find out by using Ekadikena. This is going to be 25, 16 into 17. 16 into 17. T number multiplication you can apply. 7, 6 are 42, 4, 17. 16 plus 4 is 27. So this is going to be 27225, which is little bit higher. So now this particular number, that is 27,912, lies between 165 square, right, and 170 square. Let me find out. So randomly you need to choose. Let me select 167 square. Now you need to apply Dvandva over here. 7 7s are 49, 4 carry, 7 6 are 42, 84, 84 plus 4 is 88, 8 carry, 7 1s are 7, 7 2s are 14 plus 36, 50, 58, 5 carry, 6 1s are 6, double it, 12, 12 plus 5, 17, 1 carry, right, 1 1s are 1 plus 1, 278. This is 279. So this is going to be, so therefore A is equal to 167. So we know that the formula is going to be A plus R by 2A minus R by 2A whole square, that divided by twice R by A plus R by 2A. Right. So I am not calculating this, only up to here I am calculating. So A is equal to 167 plus R, I need to find out 2 into 167. R, what is R? That is the difference, right? So 27,912 minus, right, 27,889. So 12 minus 9, or otherwise apply Nikilam Sutra. 2 minus 9 is not possible, right? Find the difference here, right? If you find the difference, right, so that is what happens here. So 12 minus 9, right? So you can check out here, right? So I think so 167 square. Let me find out 167 square, right? 167 square, which is going to be 27,889, right? Right? Fine. So now see the difference. If you find, that is going to be, so 27,912 minus, right, so 27,889. If you apply Nikilam Sutra, we are going to get a 23 here, right, 23, right. So find the difference here, that is going to be 7, 10 minus 7 is 3, right. So now next is, so take this, 1 minus 8 is 7, 9 minus 7 is 2, so it is possible here. So 9 minus 8 is 1, you are out from the complement. 1 minus 1 is 0, and then further again 0, you are going to get 23, right, which is going to be 167 plus, now you need to divide this, that is 23, that divided by 7 2s are 14 and carry, right. Otherwise elimination and retention you can apply, that is Lopana Stapanabhyam. 1 into 2, that is 200, based on the place value. 6 into 2, 12, 120, 7 2s are 14. So 320, 334. Right, now divide this 23 by 334. Take a decimal place, 0, 334. Again it is impossible, take 0. Right, 334, 300. Let us take 300. 300, 7. 7 take 7 4s are 28, 2 carry, 7 3s are 21 plus 2, 23, 2 carry, 7 2s are 7 3s are 21 plus 2 is 23. Right, 2338. So you can make it as 6. Right, which is going to be 167 plus 0.06. So therefore square root of 27,912 is going to be 167.06. So you can check out by using calculator, you can check out, or otherwise by using other method which I explained in the previous videos, you can use that also. Right, so the answer is going to be 167.06 you are going to get. Right, by using square root, by using Dvandva Yoga also you can use. Okay, fine. This is what the Bakshali manuscript method. Right, thank you.